Fast Synchronous Buck MOSFET Drivers with Dead Time Control by Texas Instruments. Welcome to the training module on TPS2831. Today's training outline consists of features and functional block diagrams, typical characteristics of the device, high-low side driver concept, control functions, CROWBAR, and application circuit. The TPS2830 and TPS2831 are MOSFET drivers for synchronous buck power stages. These devices are ideal for designing a high-performance power supply using switching controllers that do not have MOSFET drivers. The drivers are thus designed to deliver 2.4 amp peak currents into large capacitive loads. The high side driver can be configured as a ground reference driver or as a floating bootstrap driver. An adaptive dead time control circuit eliminates shoot-through currents to the main power field effect transistors during switching transitions, providing higher efficiencies of the buck regulator. The TPS2830 and 31 drivers have additional control functions, for example, enable, sync, and CROWBAR. Both drivers are off when enable is low. The driver is configured as a non-synchronous buck driver, disabling the low side driver when sync is low. The TPS2830 and 31 drivers have additional control functions, enable, sync, and CROWBAR. Both drivers are off when enable is low. The driver is configured as a non-synchronous buck driver, disabling the low side driver when sync is low. The CROWBAR function turns on the low side power field effect transistors, overriding the IN signal for overvoltage protection against faulted high side power field effect transistors. The TPS2830 has a non-inverting input. The TPS2831 has an inverting input. This slide shows typical characteristics of Q1 control MOSFET. Graphs here highlight the RDS-on values of gate source voltage 5 volts and gate source voltage 9 volts for control MOSFET Q1. Since it is more prone to switching loss, Q1 is normally selected based primarily upon lower gate charge, with secondary consideration given to RDS-on. This slide shows typical characteristics of Q2. Synchronous rectifier MOSFET. The RDS values for gate source voltage 5 volts and 9 volts for the synchronous rectifier MOSFET Q2. Since it is more prone to conduction loss, Q2 is selected based upon lowest possible RDS with secondary consideration given to gate charge. High-side gate drivers are used to drive a MOSFET or IGBT that is connected to the positive supply and is not grounded reference but is floating. High-side drivers are more complicated than low-side drivers because of the required voltage translation to the supply and because it's more difficult to turn off a floating transistor. It refers to how you drive a load. High side means your switch is between the plus power and the load. Low side means that the switch is between the load and negative power. This slide offers information about control function of TPS2831 device. Dead time control prevents shoot-through current from flowing through the main power field effect transistor during switching transitions by controlling the turn-on times of the MOSFET driver. The sync terminal controls whether the drivers operate in synchronous or non-synchronous mode. The CROWBAR function turns on the low side power field effect transistor, overriding the IN signal for overvoltage protection against faulted high side power field effect transistors. CROWBAR can be driven by an external OVP circuit to protect against a short across the high side MOSFET. If CROWBAR is driven low, the low side driver will be turned on and the high side driver will be turned off, independent of the status of other control terminals. This slide illustrates the circuit schematic of a 100 kHz synchronous buck converter implemented with a TL5001A pulse width modulation controller and a TPS2831 driver. The converter operates over an input range from 4.5 volts to 12 volts and has a 3.3 volt output. The circuit can supply 3 amp continuous load. Driving the gate of control MOSFET Q1 and synchronous MOSFET Q2 with one voltage level versus another requires careful consideration in order to weigh the benefits of one gate source voltage versus another. The RDS versus gate driver voltage and gate driver voltage versus gate charge curves for each MOSFET must be carefully looked at. These figures show a representative model illustrating most of the parasitic elements that can impact switching power supply performance. The resistance associated with the driver sink and source impedance quite often are not the same value. It is also important to mention the effect of parasitic inductance between the driver and the MOSFET. At higher frequency operations, this inductance can limit the gate current trying to charge the MOSFET input capacitance, therefore minimizing the length of trace between the driver and the MOSFET, as well as running a short and wide gate trace directly over a ground plane will reduce parasitic trace inductance.